Welcome to the tutorial series for the BIM tool. This is the first video, that's the introduction video, where I explain a bit about the whole process. And I would say I would start with a short introduction to this tool, and we decided to divide the tool into 4 parts. So that means we have here the first part, that's a part without interaction to the user, and the goal is to create an IFC file with the coordinates of each beam and each column. This part is future because we are not able to get an IFC file. The second part is a part with the user's interaction, where you can add material properties. And then the script or the Python code ends, and the rest is just for the future. So the goal is to add also external loads and include these external loads and support conditions to the model, and then run a structural analysis. And then goal is to run or to perform a structural analysis. And the last step or last part in this BIM tool is to prepare a report for the documentation. And then our process is done. The process ends here. Okay, let's start with a detailed look at the script. We start here at the beginning when the script process start. And yeah, the first thing that happens is that the script will retrieve a model. So you have to upload an IFC file, and the script will read it. And then in the following steps, the script will look for load-bearing elements, in our case, especially for beams and columns. If there are no structural elements, you have to upload a new model. But if there are structural elements, then I would say the main process starts, and the script starts to extract some properties like the tag, the slope, the length, all the vertices of one element to calculate the start and the end point of each element of the model. And we did it separately for beams and columns. So that means also we have 2 lists at the end. The script will give you a list beams and a list columns. Both are text documents. Then the next step is that the script will also extract cross sections and the material for each element. Here it is very important to say that the material that we extract here is the material name. So that means it is not the real material with some properties, it's just the name. So in the next videos I can show you which names I mean. And then the last step of the first part from the script is to create an IFC file with all coordinates of the beams and columns. That is actually a feature. We are able to create a list with all coordinates, but we don't have export an IFC file. Yeah, that's the first part of the tool. You have no interaction with the tool, and the first interaction from the user comes in the second part, which begins here. And here the script extract the materials that are used in the model, and here the materials that are extracted are something like metal, concrete, and that stuff, and we'll save it into a list material. And here we have a CSV file instead of a text file because we want to edit it. And here comes the first interaction with the user. The user has to open the CSV file, and then he can add material properties manually. So we can decide or type in the density, the compressive strength, the yield strength of the different materials that the script extracted for us. And then we have to save the CSV file, but it is important that you use Excel to avoid an error message. We figured out that when we are not using Excel to do that, we get the error message, file cannot save because file is in use. And that is because the script runs the whole time in the background. Just wait for your interaction, and this interaction comes now this last step of the interaction, you have to go back to your command line in the code environment and follow the instructions in the command line. And you just have to pressing Y, doesn't matter if it's capital or small, and then hit enter. The script, or you've saved the CSV file, and then the script will take this CSV file with the updated list of materials and add all the material properties that you typed into this list and add it to each element. And now we are able to calculate the dead load, for example, for each element. And yeah, and then we will also end the second part of our script. Now comes the third part. Here we are, or the user has the opportunity to include external loads and support conditions. So external loads can be wind loads, seismic loads, snow loads, live loads, whatever the user wants to add or include to the structure, he can do it here. Also the support conditions. And now the script should be able to perform a complete structural analysis, and then you get a report or feedback, and then you can decide are the results acceptable. And then you have, then you can decide between you modify the structural design and update the source model, so you uploaded a new model, or that's the other option, you modify the element properties and also go back to the designing process. But if you say, okay, yeah, the results are acceptable, then you can say, okay, prepare the report for the documentation. And then our script ends and the process is done. And you hopefully have a final report.